accumulator. Or end. No, wait. Oh, okay, wait. Hold this thought. Okay, so if P0 is on, then we have a time value in the accumulator. Maybe we could handle the termination in separate in the microcontrollers. So move accumulator x3, move accumulator x2. 8, 4, 5, 6, 9. Okay, so in this case, move x0 accumulator. Okay, so once again, I need to take a look at the supplemental data. Okay, so this is handling the laser. So if it's test less than accumulator 3. If it is, move 0 P1. Otherwise, let's see. Otherwise it needs to be on. So test greater than accumulator. No, 4. If it's not, move. Wait, 50 P0. Wait, or P1. Jump and P1. Okay, I think that should handle the laser, but in this case, move x0 accumulator or x1, and let's see. Okay, so test greater than accumulator 4. If it is, 0 x3, jump end 1. If it's not, less than accumulator 3. It is. To switch on the 20-degree flood, so move 100 x3, and if not, move 1 x3. Okay, I think this should work, but let's start testing it out, see how this goes. Oh, okay, no. Okay, well, let's. Oh wait, no. 1. Oh, okay. 0. Alright. Let's try that. No. What happened? Okay, two time units, so the 20-degree flood should be on. Or no, or wait, no, 60-degree flood should be on. Okay, so You know what, let's do that instead. So, let's move 10. Alright, let's try that. Advance. Okay, that's solid. Yeah, it's looking like it's holding in all situations. Heart not sleeping, block on right. Okay, wait. How did that happen? Okay, is there a different radar out? Okay, 2, 3. But how am I supposed to know when the radar out is supposed to go? Okay, well, clearly the initialize is not helpful. Is there some sort of indicator as to when it's supposed to go out? Okay. What about the information? Are we going to get some sort of simple input connected, or it's an input? They're both inputs? Okay. Oh wait, no. Okay, it's an input. Okay, so 2. Okay, so once again. Okay, let's start over. Test greater than P1, 0. If it is, then we're getting a pulse in. Move that. Okay. Let's try that. Wait, what? Heart not sleeping. Oh. Otherwise, sleep 1. Okay. Okay. Yeah, that should solve it. Okay, just simulate. Because the handling seems to be fine. And yeah, there we go. Okay, so it looks like most people handle this with a production cost of 9. And they managed to use less power than me, and I used way more code, but whatever. This is my solution. That's all I care about. Alright, from Carl Teskey. We did it! We made some kind of thing that goes on another thing that's made for killing people and helps them kill people even better. Yay! Go us! From Wu Li, Carl, I understand your concerns, but let's take this offline. Well, that was pretty good. Let's take a look at the next one. Project Haunted Doll. From Joe. Hey, so I was doing some research on the internet. It seems that if a doll is a haunted doll, it brings way more interest. Haunted dolls that get caught on a live stream are almost guaranteed to go viral. So what if we took some of the dolls from our factory around here and put some parts in them to haunt them, then distributed them along with the normal dolls to toy stores? Oh my god, haunted doll! We just have to keep it a secret so it doesn't leak that we're manufacturing them here. From Wu Li, Joe, are you serious right now? Li Wu. From Carl Teskey, this is brilliant. I love this. I found some appropriate sound effects online. I think Sinister Giggle and Blood Curdling Cry are the best of that bunch. Now we just need a random number generator. preferably a haunted random number generator. And from Zhang Ji. We have some unmarked chips from a long time ago in storage. The original purpose or maker is unknown. Seems interesting. I put some in the prototyping bin also. Perhaps this part was created by a ghost shift. Oh, the pun. That is some joke. That's just some joke. Humor. G. From Carl Teskey. Perfect, Jay. Let's go terrify some live streamers. Alright. And as usual, the information is here in the supplemental data. Specifically, it's Dark Lord 555's creepy sound effect page. This page was designed for Internet Explorer 3.0 or better. Whoops, I don't think this is visible anymore, really. Oh, and you are the 1,792th visitor to this page. And yes, that's how I'm pronouncing it, because that's how it's spelled. You have found yourself in a dark wood, in a huge forest with no beginning or end. What is that noise? Before you know it, the darkness has taken you. These sound effects were recorded and modified by me, Dark Lord 555. They are free to use. You can use these sound effects to scare your little sister or whatever, I don't care. So we've got a sinister giggle, giggle.wave, an unsettling laugh, laugh.wave, a blood-curdling cry, cry.wave, startling crash, crash.wave, and creepy singing of Ring Around the Rosie, ring.wave. You know, it would be interesting to experiment with this in the testing. But yeah, each audio clip has a string of numbers assigned with it, and we're about to learn what that's to do with. Oh, yeah, web address, but I doubt this is a real web address. But anyway, I suppose let's get a start on that. Okay. Random is a simple input connected to a random number generator. And it looks like it's here on this chip. Speaker is a simple output connected to a miniature, self-amplified audio speaker. When a value of 1 is randomly generated, play the sinister giggle sound effect, and when a value of 2 is randomly generated, play the blood-curdling cry sound effect. Look for the supplemental data in the manual for the audio data that Carl found for these sound effects. Alright, so we're actually going to need I think now we're going to need a new chip. In fact, yeah, we're going to need random access memory, I believe. Yeah, so we're going to need this 100p14 random access memory chip. Okay, so actually, this would be a good time to actually look at the documentation on that chip, because, you know, I'm trying to fill time to make these parts come out even. So, oh, here it is, 100p14, random access memory. Yeah, so the 100p14 random access memory by Ping.co Limited offers embedded system engineers additional storage for today's increasingly data-driven world with a whopping 14 memory cells. With its convenient auto-increment feature, you won't have to waste precious registers keeping track of memory addresses. Features 14 random access memory cells, 2 independent auto-incrementing memory pointers. Usage: all memory cells initialized to a value of 0. All memory pointers initialized to the point at the first memory cell, address 0. Memory pointers can be read and written over XBus with the A0 and A1 address pins. Memory values referenced by pointers can be read and written over XBus with D0 and D1 data pins. After reading from or writing to a data pin, the corresponding memory pointer will automatically increment to the next memory location. Example circuit: data packet reverser. The following example circuit reads in 3 value packets from input and writes them back out to output in reverse order, using a 100p14 to temporarily store the values. So, say, move 0 to x3, moves x0 to x2, move x0 to x2, move 0 to x2, then be in reverse, move 2 x3, move... Well, we could probably handle it with a loop.